Hello everyone and welcome back. So this is the second video in our series of examining if demographic factors influence 311 requests such as graffiti removal, trash disposal, street repair, and so on and so forth. Sorry, give me 1 second. So as a reminder, the primary purpose of this particular video series is to examine if social economically advantaged neighborhood councils make more 311 requests, and if social economically advantaged neighborhood councils resolve their 311 request more quickly. Now, in the previous video of population analysis, I went over where I got my 311 request data, as well as my demographic data. The two links you see on this slide have been provided in the description below. Now, for the second video in this series, we are specifically looking at age and its impact on 311 requests. Now, there are 4 hypotheses concerning age. The first hypothesis is that neighborhoods with older populations should have more 311 requests. In general, older populations are often retired and have more time to canvass the neighborhood and take notice of particular problem areas. On the other hand, the second hypothesis postulates that younger neighborhoods have less 311 requests. In general, younger neighborhoods, especially children under the age of 15, are either caught up with school or are really just focusing on growing up. And thus they might not have the time to notice issues within the neighborhood. The third hypothesis postulates that neighborhoods with older populations are often faster to resolve 311 requests. In contrast, the fourth hypothesis postulates that younger populations are slower to resolve 311 requests. The rationale here is that the cities would be more willing to listen to the concerns of adults as opposed to the concerns of younger people. Now let me switch over to the tableau, which is where I conduct most of my data analysis. Now, on this slide, we assess age groups for each particular neighborhood councils. So on the left, you can see the names of each of the neighborhood councils, and on the bottom, you can see the particular age groups. And here we see that the age groups are divided into 4 sections. We have those who are less than 15 years of age, which are represented by blue. We have those who are between 15 to 19, which is represented by green. We have those between the ages of 30 and 64, which are represented by yellow. And lastly, we have those who are over the age of 65, which are represented by red. Now, if you look at the bottom, I guess you should say the x-axis, you'll notice that it signifies the population of each particular age group. If you notice, though, in the 30 to 65 age range, that the x-axis is significantly longer. It goes all the way up to 50K, in fact. This is the largest of all 4 of the age groups. And second to that, though, is the 15 to 29 age range, which goes all the way up to 30K. Thus, the majority of people for the Los Angeles region are actually within the 30 to 64 age range. If we go to slide 8, here we see a graph showing the median age of each neighborhood council. If you scroll down at the right side and you notice those labeled numbers, you'll see that the majority of those neighborhoods are within the 40 through the late 30s age range. I mean, you'll see some in the early 30 age range. So again, that's the second highest group. No, that's still within the highest group, though. And you'll see some 20-year-olds here and there as well, but again, not the majority of them are within the 30 to 40 age groups. Now, the reason why I show you these two graphs is in order to bring context for our regression analysis and why the regression kind of turned out the way it did. So we go to slide 6, and here I perform the regression analysis of individual age groups, of the individual age groups that you see on the x-axis against the count of 311 requests, which is on the y-axis. For here, the age 15 and younger had a strong r-squared value, had the strongest r-squared value, in fact, of 0.62236, again, which is the highest of all four of the r-squared. The age 15 to 29 had the second highest of 0.56215, and the age 30 to 64 had also a high one, though not as high, of 0.482266, while the only one with r-squared value which was not strong was surprisingly the age 65 and older. Now, for those of you who don't remember what r-squared means from the previous video, the r-squared value represents the proportion of variance for a dependent variable that is explained by the independent variable. The r-squared is to show you correlation between the two variables. Now, in this particular case, let me switch back to my PowerPoint. In this particular case, both hypothesis 1 and hypothesis 2 are incorrect. The age 65 plus age range, remember, which only had a r-squared value of 0.15, indicates that there was no correlation with the amount of 311 requests, and thus it disproves hypothesis 1. Furthermore, age 15 and under, if you remember, it also had the highest r-squared value of 0.622, and so that contradicts the second hypothesis, which is claiming the opposite. So that means what we can conclude is that older populations do not have more 311 requests, or at least the neighborhood councils that have older populations, while on the other hand, neighborhood councils that have a large younger populations actually do have a greater amount of 311 requests. I'm wondering if that has something to do with having parents or something like that, but that's beyond the scope of my analysis. So if we go back to the tableau, we can now see the regression for the between. I apologize, my screen just turned off. We can see the regression between the age groups, as well as how quickly the problems are resolved, how quickly 311 requests are resolved. And unfortunately, there was I would say there was issues, and so which we'll get into right now. So here, when I ran the regression, if you'll notice the box on the lower left, you'll see that many of them had p-values that are greater than the acceptable threshold of 5% or 0.05. Now, p-values, for those of you who don't know, is a statistical measure that assesses if a graph is statistically significant, meaning that the values generated aren't a fluke. things like that. And so as mentioned, as by that definition, since all four age groups had p-values that were greater than this 5% threshold, that means that it's it's hard to it would not be advisable to rely on these graphs to draw conclusions from them. And so, well, so a lot of the data here, it signifies that it's inconclusive. Basically, you can't don't know if there's a correlation or not. So, as I did with the population regression, as if you recall, there is this one outlier here for downtown LA, and when I remove it, I was hoping that that it would help fix the p-values. Unfortunately, when I did that, still 3 out of the 4 age groups still had a higher than acceptable p-value, and thus it makes the data inconclusive. The only one which had acceptable p-value when the outlier was removed was the age 65 plus range. When here their p-value is 0.039, which is below the acceptable threshold of 0.05, and thus here it hits r squared. The corresponding r squared for the age 65 plus was only 0.0445, and so this is a low r squared value. In other words, the only thing that we can conclude from this regression analysis, from this particular regression analysis, the one related to age group and date difference, or age group and resolution speed, is that there is no correlation for elderly population neighborhoods and with how quickly their 311 requests are resolved. And so if we go back to the PowerPoint, if you look at hypothesis 3, hypothesis 3 postulated that the older population had faster resolutions. However, as we saw from the regression analysis earlier, this is incorrect because the r squared value was simply too low, and thus it indicates there is no correlation between resolution speed, 311 resolution speed, and the elderly age, and thus hypothesis 3 is incorrect. Hypothesis 4, unfortunately, because as you saw from the regression analysis, with its bad p-values, is inconclusive, and thus I cannot answer hypothesis 4 based on the data provided. Anyway, that's it for age. I'm hoping that you'll return when we go over our next demographic factor in the next video. Thank you for having me.